Okay, so today is our second review for the linear context and exponential stories. So when we go over the linear stuff, this is just converting between the four different types of linear expressions, right? The story, the table, the graph, or the linear equation. So in order to write any kind of linear expression, you need two things. You need a slope and you need a y-intercept. So our task really to convert between these different expressions is to identify a slope and a y-intercept from what's given, and then we can graph or write or whatever the rest of these. So for example, on this one, you have 30 puppies. Each day you give 6 puppies to a new home. So when you are finding a slope and a y-intercept, the y-intercept is always going to be something that is a starting point or a one-time fee or something like that, because that means it's going to be adding in your equation. And since we are starting with 30 puppies, that is going to be my y-intercept, 30. That's where my line is going to cross the y-axis, and that's where I start on pretty much everything, is the y-intercept. And then that means that the slope is going to be 6. Now, you can tell it's a slope because it's going to have like those keywords like each or per or every. That means it's multiplying with something. And the slope is always multiplying with the x, because again, the linear equation is y equals mx plus b, where m is your slope and b is your y-intercept. Don't ask me why they use m and b. It's probably some kind of Greek letters or words that mean the same thing, but that is what it is. Okay, so that's going to be, our slope is going to be 6, but then we got to figure out if it's going to be a positive 6 or a negative 6. So if I have 30 puppies and each day I give away 6 puppies, am I going to be gaining 6 or losing 6? I would be losing 6, right? So that means my slope would actually be negative 6. So that's going to be the one tricky thing to think about, is think about when I go, am I going to be going up or down? And if you're going down, that's negative, right? Nice, negative. So equation is usually the easiest one to do because you just plug these two numbers into your equation, right? The y and the x are always there, and then you're going to have something adding and something multiplying with the x. The slope multiplies, so it'd be negative 6x, and the y-intercept adds, so plus 30. Okay, and that would be your linear equation. That's all there is to it. Next thing is the table, and we always start at the y-intercept on the table. When you're on the y-axis, your x value is 0. So the x value of your y-intercept is always going to be 0. The y value is going to be whatever your y-intercept is, so it's going to be 30. Next thing is I look at my slope. My slope was negative 6, right? Or negative 6 over 1. Slope is your rise over your run, or your y over your x. So what this is saying is that I'm going up 1 every time on the x, and I'm going down 6 every time on the y. So the x's are going 1, 2, 3, 4, 5, blah, blah, blah. And then the y's are going down by 6. So 24, 18, 12, 6, 0. And I don't know if you can get negative puppies, but I don't think you can. So that'd be weird. Okay, and then the graph. This is your y-axis, right? This is your x-axis. So y and x. And this does not go up 30 times. So what I'm going to have to do on some of these is I'm going to have to change the scale. So let's change the scale so that it is going up by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 30. I put an extra number in there. No, I skipped a number. Sorry. I started going by 6s. So 18, 21, 24, 27, and then 30. Okay. Now, I'm going to have the x's still go by 1s over here. And to graph it, I start at my y-intercept, and then I would go down 6 over 1, right? So I'm going to go down 6 over 1. And as I do that, did I miss a number? I think I skipped a box. Okay. Well, anyway, it's going down 2 over 1. It's going to end at 5, right? So when we look at these points and what I just graphed, I should be graphing points at 0, 30, at 124, 218, and so on, right? That's all these points are. Okay, and that's me converting it to all the different expressions. Let's look at another example, and I'm going to go much quicker on these because I've done everything. I'll spend a little bit more time on the context, but I'm going to go much quicker over these. So again, if you're struggling with either of these, go back and look at number 1. So from the table, I need to find a slope and a y-intercept. So slope, y-intercept. Intercept. So the y-intercept is always whatever the y value when x is 0. So that means that it would be 2, right? The slope is the change in y over the change in x. This is going up by 4 on the y and going up by 1 on the x. So the slope would be 4, or 4 over 1. So to write that as an equation, by equals the slope times x, so 4x, and then plus your y-intercept, so plus 2. And then to graph it, I'm going to start at 4, so start at 2, 1, 2, and then I'd go up 4 over 1, up 4 over 1, up 4 over 1, and that would be my graph. And then for the story, again, for the story, your y-intercept is like a starting number, and then 4 is like happening per day or something like that. So, for example, like one story is Mr. Anderson has 2 annoyed students. Every minute he talks, he annoys 4 more. Okay, but that works, right? Now the y-intercept is what I'm starting with, and then for every minute, I'm annoying 4 more. So it works. And is accurate. Okay. Next one, we have a graph, and I need to find a slope and a y-intercept. So slope, y-intercept. So y-intercept is where it crosses the y-axis, right? So if this is going up by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be hitting at 10. So y-intercept would be 10. Now if I wanted to change that scale, I could, but for your test and stuff, I'd probably just stick to 1 on these if you can count to it. Makes it easier to make sure it gets right on canvas. Okay, and then the slope is the rate which is going down. It's going down 1 over 1. So that would be a -1 slope, right? So -1, or -1 over 1. So your equation would be y equals -1x, or just negative x, because it's the same thing, right? And then you would add 10. And then for your table, you would start at the y-intercept, so that means x is 0, and the y would be 10. And then the x's are going up by 1s, so 1, 2, 3, 4, 5, 6. And the y's are going down by 1, right? Because that's why the line's going down. It's going down 1. So 9, 8, 7, 6, 5, 4. And that'd be your table. Not too tough, right? And then the story, Mr. Anderson has $10. Mrs. Nebeker steals $1 every day. All right, that fits. 10 is the starting amount, and then I'm losing $1 every day. So it fits my linear situation. Okay, this last one gives me the equation. So that's usually the easiest to decipher, right? Slope, y-intercept. Y-intercept is the number that's adding, so that would be 7. And the slope is the number that's multiplying with the x, so that'd be 2. Not too tough, right? Do the table, x would be 0, y would be 7. And then the x's are going up by 1, right? Because it's 2 over 1. So 1, 2, 3, 4, 5, 6. And the y's are going up by 2. So 9, 11, 13, 15, 17, 19, so on. For the graph, I would start at 7. So 1, 2, 3, 4, 5, 6, 7. And I'd go up 2 over 1. And that would be my graph. So the line would look something like that. And then for my story, let's say Mrs. Lloyd has 7 Seahawks shirts and buys 2 every day. And that works, right? Starts at 7, goes up by 2 every day. Fits. Okay. If you have any questions or concerns, come talk to your teachers. We're here to help. We want to help. Just need you to talk to us. So we'll see you in the next video probably.